Hello students, in this video,
Third sum, prove that a square BC AC plus C square, a square plus AB, AB, B square plus BC, AC, C square is equal to 4 times A square, B square, C square. So now here the right answer is not 0. It is some 4 times A square, B square, C square. So first you check column wise and row wise if there is anything common. If there is anything common, you take it out. So you try to simplify this matrix. Now if you see column 1, what is column 1? What is common? A. So let us take A from column 1. Column 2, B is common. Column C is common. So if you take it like that, you get first column will become A. This is A square become A. This will become A plus B. And you have taken out A, so become B. And from here we took it B. So first column you have C. First element is C. And here B. And you have taken out B. So it will become B plus C. And third column you have taken out C. So you will get A plus C. And C you have taken, so A and you have C. Now try to simplify this. If you add, if you can take anything common, or just use the properties and simplify this. If you straight away expand here, difficult for it to expand. So use the property. So what I am going to do here is, I am going to subtract these two. So this B and B will get cancelled. I am going to subtract R2 and R3. Because I wanted to eliminate this B and B. Okay. So when you subtract, what do you get now? A, B, C. My aim is to simplify this. So first row, I am not doing anything. A, C, A plus C. Second row, subtract A plus B minus B. A. Yeah. B minus C. Minus C you will get, right? C. B minus B minus C. So B and B get cancelled, but one minus C is there. And here you have A minus C. Now third row as it is B, B plus C, C. Now again try to simplify this. You can just think and tell me. Can you do something and simplify it? Get 0. Try to bring one 0. Yeah. Add. Very good. Which one you are going to add? R1 and R2. Correct. You are right. So you can bring some 0. Our aim is to simplify this determinant. So we can bring some 0 here, because if you add, you know this will become 0. So this is ABC. You are adding A plus A, 2A, plus C minus C, 0. This get cancelled and you get one 2A. Second row we didn't do anything, as it is. B, B plus C and C. Now what is the next step? Anything common? First row, 2A. 2A is common. 2A, 2A. So we can take out the 2A outside. So 2A I am taking out. Already one ABC is there. So when you take out 2A out, I get 1 here, 0 here, 1 here. And second row as it is. B, B plus C and C. Now can you bring one more 0? So it will be easy for you to expand. C1 and C3 you can subtract. Isn't it? C1 and C3. If you subtract, you will get 1 0. So this will become now 2A, ABC, subtract 1 minus 1. Column 1 and column 3 I am doing. I am not touching column 2. Column 1 minus column 3, 0. 1 minus 1, 0. What happened here? If you subtract, what will you get? A minus, yeah, very good. It will become plus C. And this will become B minus C. Second column as it is. Third column as it is. Now enough, we got 2 zeros in a row. Now you can expand. Expand means find the value of the determinant. You learned the expansion yesterday. You can use row 1 to expand. You can use any row. You learned that property yesterday. To find the value of a determinant, you can use any row. I am using row 1 because I have more zeros here. Okay, so this is equal to 2a, ABC, 0 into anything is 0, right? So that you need not find at all. 0 into cut this row, cut this column, this 0 also you can cut it off. Okay, plus 1 into, what is the minor? This one, right? Isn't it? For 1, so write that C, I cross multiply. Okay, I'm just cancelling this row. Okay, 1, this row, and this column I'm cancelling. So I get this. So you will get now C into B plus C minus of, put one minus sign, B minus C into minus C. This minus sign is very important. So C into B plus C minus B minus C into minus C. So this is equal to 2A square BC, and all these are zeros only you have here. Multiply now CB plus C square. Now minus, here one minus BC, right? Minus BC into minus become plus BC. Then minus into minus plus C square minus C square. So these two will get cancelled. So you have now 2A square BC and 2BC here. Isn't it? BC plus BC is 2BC. So what is the final answer? 4A square B square C square. So we have proved this is equal to the right hand side. Fourth one, prove that 1 plus A, 1 plus B, 1 plus C is equal to ABC 1 plus 1 by A, 1 by B plus 1 by C. Take the left hand side. 1 plus A, 1 plus B, 1 plus C. So if there is anything common, take it out. That's the first rule. Whenever you see a determinant, just check whether anything is common. Any row, any column, check all the rows, all the columns. Anything common? Nothing. So next aim is to simplify. Okay, simplify means try to bring zeros. If you can't take anything common, try to bring zeros. How do you bring zeros now? C1, C2 is, C2 you are taking, no? Or R2 also, R1, R2 also you can take. C2 minus C3 you are taking. So the first column as it is. First column 1 plus A, 1. Second column subtract now. 1 minus 1, 0. 1 plus B minus 1 will give you B. 1 minus 1 minus C. Minus C. You are subtracting 1 minus of 1 plus C. So 1 minus 1 minus C. So it will give you minus C. Now third column as it is. Can you bring more zeros? C1 minus C3. Don't do R1 minus R2. Can you tell me why? Problem is the other 0 will go off. Isn't it? You will get 1 0 here. See, 1 minus 1 you get a 0 here. This minus this will become minus B. So already you got 1 0. That 0 it should remain there. So think like that. So don't do R1 minus R2. You can do as you said C1 minus C3. C1 is C1 minus C3. So you should use the property without affecting the previous zeros. So now C1 minus C3 plus A minus 1. A 0 minus C here. The second column as it is 0, B minus C. Third column 1, 1, 1 plus C. Anything else? Anywhere you can bring zeros? That's all. Because if you subtract this, the 0 will go off. If I do this, you will lose this 0. Isn't it? So let us stop here. Already we got 2 zeros. If you can simplify something, you can do it. Expand. Just expand. If you cannot bring zeros, just expand using any row. Anyway, this row has 1 0, this row also has 1 0. So we can use row 1 itself. Either choose row 1 or row 2. So let us choose row 1. So you know to expand A into, cut the row, cut the column, its cofactor. B into 1 plus C minus of, that minus you put, then only you should multiply this, minus C. A into, cut this row, cut this column, B into 1 plus C minus of minus C minus 0. 0 you can just omit. Plus 1. This is, you know the sign, plus minus plus. Plus 1 into its cofactor. 0. This is 0. 0 minus of, then you multiply this. So just put the minus sign, put the brackets properly. So 0 minus of minus BC. Okay. Now you multiply this. This is equal to A into, open the bracket first, B plus BC plus C. This is, yeah, this is 0. And here you get plus BC, correct? Plus BC. Now multiply this AB, ABC plus AC plus BC. This is the answer that we got, but that's not the answer. They want to take ABC outside. So divide by ABC and multiply and divide by ABC. So what happens when you divide by ABC? Multiply by ABC, divide each term by ABC. What do you get? If I divide this AB by ABC, what will I get? 1 by C. What will I get here? 1. What is this? AC by ABC? B. 1 by B. This will give you, next will give you 1 by A. So that's the answer. This is equal to the right hand side. Can rearrange and write. They have written 1 plus 1 by A plus 1 by B. So rearrange it and write. This is ABC 1 plus 1 by A plus 1 by B plus 1 by C. Sum number 5. C1 is C1 minus C2. You can use the trigonometric identity. What is the identity? 1 plus tan square theta is secant square theta. So secant square theta minus tan square theta will become 1. Okay, you can use that. So to remove this trigonometry, we do column 1 and column 2. So this is equal to, so what do you get now? Secant square minus tan square. Minus tan square. First column I am changing. Second element is tan square theta minus secant square theta. 38 minus 36 is 2. The second column as it is. Secant square theta and 36. Third column 1 minus 1, 2. Now tell me, what is secant square theta minus tan square theta? 1. What is tan square minus secant square theta? Minus 1. 2. Tan square theta, very good, 0. Why it is 0? So you can see here, these two columns are identical, equal. C1 is equal to C3. So you know the property of determinant, the value is 0. So same number, two columns have the same number. So the determinant value is 0. If you expand also, you get the same answer. But because you know the property, we can always use the property. So it is equal to the right hand side. This is the left hand side. I took the left hand side and we got 0, that is equal to the right hand side. So we have proved. Sixth one. prove x plus 2a, y plus 2b, z plus 2c, x, y, z, a, b, c is equal to 0. So take the left hand side. There is one property: when any row is expressed as sum of two terms, you can write the determinant as sum of two determinants. Repeat, if any row is expressed as sum of two terms, then the determinant can be written as sum of two determinants. So here you can see the first row is expressed as sum of two elements, isn't it? So we are going to split this as two determinants. In the two determinants, the second row and third row, we are not going to do anything. Second row and third row, we are going to write as it is. Okay, second row is x, y, z, a, b, c. Here also second row as it is: x, y, z, a, b, c. Now first row, what do you write? The first element, the first row of the determinant is the first elements. So what is the element? X, y, z. Here what will you write? 2a, second elements: 2a, 2b, 2c. Now this is 0. Why? Why? You should write the reason. R1 is equal to R2. You can see that rows are equal. See, XYZ, XYZ. So it is equal. What about here? This is also equal. Why? If you take out this 2, actually you did not take 2 common. You can just write R1 and R3 are proportional. See, A is ABC in the R3. And you have 2a, 2b, 2c, or you take out 2 and they'll be equal. You need not take it out and write again. You just write R1 and R3 are proportional. Proportional also, the determinant value will be 0. Remember that. If two rows or two columns are proportional, proportional means it is multiplied by a scalar. The difference is only in a scalar multiplication. So these two are equal to 0. So that means it is equal to 0. Hence we have proved. 15th one. 3x is common. 3x outside. What do you get now? First row 2, 3, 4. Second row 5, 6, 8. Third row, what do you get here? 2, 3, 4. So two rows are equal. You can see R1 and R3 are equal. So what is the determinant value? 0. What we should do here? Written a sum of two terms, so split. Or one more thing you can do. See, x plus y. What is missing here? Z. What is missing here? X. What is missing here? Y. If I add that, that means you can write R1 is R1 plus R2. If I put R1 plus R2, I will get, what will I get in the first row? Tell me. If I add R1 and R2, if I add like this, what will I get? X plus Y plus Z. Everywhere I'll get the same term. X plus Y plus Z. X plus Y plus Z. Now, what I should do? This is common, you take it out. Isn't it? X plus Y plus Z is here, X plus Y plus Z, X, take it out. What will you get if you take it out? You will get here 1, 1, 1. So now you can see R1 and R3 are equal. So the value of the determinant is 0. So this value is also 0. Or the other way of doing it is split and do it. But this looks very easy because something is missing and it is here. Z is missing but it is there in second row. X is missing, it is there in the second row. Here Y is missing, it is there. So if you add, you will get X plus Y plus Z. Take it out. When you take it out, you will get like this actually. 1, 1, 1. Second row as it is. And third row 1, 1, 1. And outside you have X plus Y plus Z. Okay. the value is 0 because two rows R1 is equal to R3. So that means it is 0.